Hello everyone and welcome to Network Labs. Today in this video, I will share how to configure ISIS, MPLS, L2VPN, and L3VPN to build a service provider network using Huawei routers. In the diagram, I use two routers, PER1 and PER2, as the edge routers facing the customer's devices. For our task, establish connectivity between PC1 and PC2 using MPLS L3VPN. Establish connectivity between PC3 and Switch 1 using MPLS L2VPN. To achieve our task, follow the steps and procedures below. IP addressing within the service provider network is pre-configured with details on the screen for loopback and link addresses. For configuration, we will begin with the IGP protocol, which is ISIS, for end-to-end connectivity between PER1 and PER2. Then, MPLS LDP for label distribution. Next is BGP for VPNV4 to carry VPN routes. Then MPLS L3VPN and L2VPN services. Once done, connectivity between the customer sites should be successful. Conduct link connectivity between PER1 and PER2. Now, let us proceed with the IGP configuration. Configure ISIS process on both PE routers. Set the process ID to 1. Set the ISIS level to level 1 only. Modify the metric or cost style to wide. And net device ID using the details on the screen. Configure the IS name. That is all for the global configuration. Let us input the command step by step. On the system view, configure the ISIS process followed by the process ID. Then the IS level. Then the cost style. Next, the network entity ID. Last is the IS name. We are in PER2, so we need to change the system ID. We are done globally. Repeat the same process of configuration in PER1. Next, enter each interface and advertise to the ISIS process. In PER1, enter the loopback interface and enable ISIS. Then the interface facing PER2. Set the circuit type to point-to-point. Last is the circuit level. Do the same configuration in PER2. We are done with ISIS configuration on both routers. Use the commands on the screen to see the ISIS neighborship and routing table. In PER2, the neighborship with PER1 is now up, and the loopback address is installed in the routing table. Ping is also successful. The same status in PER1. Next, configure MPLS LDP for label distribution. Here the configuration is straightforward. Globally, set the LSR ID and use the loopback 0 address of each PE router. Then enable MPLS and enable MPLS LDP globally. Go to the interface link within the network and configure MPLS and LDP. Let us begin with PER1. Globally, configure the LSR ID, then MPLS and MPLS LDP, and the interface link. Repeat similar configuration in PER2. PER2 is also done. Use the following commands to view and verify the status of LDP sessions and peer. LDP information is complete. Basic MPLS LDP configuration is done on the network. Next step is to configure BGP within the network to carry VPN routes. IBGP will be configured within the network since both routers lie in the same autonomous system. Let us start with PER1. Enter BGP followed by the AS number. Under the global BGP, set the router ID and use the loopback address. Establish IBGP neighborship with PER2. Then set the loopback interface to be used for BGP connection. Enter IPv4 address family, then enable the BGP neighborship with PER2. Configure next hop local. Then advertise or send community. For VPN routes, configure VPNV4 address family and do the same configuration with IPv4 family. Copy and paste the configuration to PER1. For PER2, edit the BGP router ID and peer IP details both in BGP Global, IPv4 address family, and VPNV4 address family. Copy and paste the configuration to PER2. Now, check and verify the BGP peer information on both PER1 and R2. BGP neighborship on both routers is now established. Our network is ready to carry the different services of MPLS upon configuration of basic ISIS, MPLS, and BGP-VPN-V4. Before we proceed with L3VPN, let us configure VRF or instance in PER1 and PER2. To configure in Huawei routers, input the command IPVPN instance followed by the name, which is yellow in this lab. Enter IPv4 address family. Then, configure the route distinguisher. Then define the export and import route target values. Copy and paste the configuration in PER1. edit the route distinguisher value, and apply in PER2. Let us continue and configure L3VPN to accomplish our first task. First, establish a link connection between PER1 and CER1. Configure point-to-point IP address. In CER1, configure the IP address globally. In PER1, bind the VRF in the interface facing CER1, then configure the IP address. Make sure that link connectivity between the devices is successful by ping testing. Do the same configuration in PER2 on the interface facing PC2. Bind the VPN instance to the interface facing PC2. Make sure that link connectivity between the devices is successful by ping testing. After PE to CE link connectivity, we will use OSPF between PER1 and CER3. In PER1, create an OSPF process for VPN instance yellow. Then import BGP to OSPF. Use Area 0 and advertise the link facing CER1. Under the BGP process, create a new IPv4 address family for VPN instance yellow. Then import directly connected routes, static routes, and OSPF routes. Apply the configuration in PER1. In CER3, configure the basic OSPF process globally. Create a loopback interface and configure an IP address for the router ID. Create an OSPF process followed by the router ID. Use Area 0. Then advertise the link facing PER1. Upon link advertisement, we can observe that the OSPF neighborship between CER3 and PER1 is established. Now, establish link connectivity between CER3 and PC1. Then advertise the link to OSPF. In PER2, for future purposes we will also configure OSPF under VRF yellow, since the link to PC2 is direct and there is no need for another routing protocol. Under BGP, create a new IPv4 address family for VRF yellow. Then, import or redistribute the link to PC2 into BGP under VRF yellow. End-to-end configuration for Task 1 is done. Let us check the routing table of each PE router. In PER1, the routes of CER3 and the link of PER2 to PC2 are now installed in the BGP routing table. In PER2, the routes of CER3 are also installed in its routing table. For VRF, or VPN instance yellow in PER2, all the routes are also installed in its own routing table. CER3 also installed the routes in its OSPF routing table. Ping from PER1 to PC2 is successful. Also, the ping from PER2 to PC1 is good. Now let us proceed with the end-to-end ping testing between PC1 and PC2. PC1 and PC2 can reach each other. Task 1 is done using MPLS L3VPN to establish connectivity between PC1 and PC2 via VRF yellow. Now let us proceed with task number 2. Here, customers PC3 and switch 1 need to have a transparent connection using the MPLS network. One way to achieve this is to configure L2VPN. Let us start in PER1 facing PC3. First, configure the VSI, or virtual switch instance. Use LDP as the PW signaling protocol. Next is the VSI ID, which must be the same on the neighbor PE router. Then specify the peer address or neighbor PE router. Next, bind the VSI to the interface facing the customer. Here, the link requirement must be in access mode, since it is directly connected to PC3. That is for PER1 facing PC3. In PER2 facing switch 1, the requirement is a trunk mode using VLAN 500. Enter the interface globally, then exit and create a sub-interface link. Use .1Q as the encapsulation type. And bind the VSI instance created. Begin and apply the configuration in PER1. First, make sure that MPLS L2VPN is activated globally. Start by creating the VSI interface, then the PW signaling. Next is the VSI ID. And the peer ID, which is PER2's loopback address. Bind the VSI to the interface facing PC3 in access mode. Go to PER2. Enter the physical interface. Create a sub-interface using VLAN 500. Followed by the encapsulation type. Then bind the VSI instance. Enable MPLS L2VPN globally. Configure the VSI instance. PER2 is done. Go to switch 1 and configure VLAN 500 with the assigned IP address. Set the switch name. Create VLAN 500 and description. Then configure the interface facing PER2. Set the interface to trunk mode. Then tag VLAN 500. Create a switch VLAN interface for VLAN 500. Then configure the IP address. Switch 1 is done. Conduct a ping test facing PC3. The ping is successful. The MAC address of PC3 is detected in switch 1. PC3 can also ping switch 1. Task 2 is done, wherein we have configured L2VPN for a transparent connection between PC3 and switch 1. With this, we have successfully completed our tasks. We have configured basic ISIS, MPLS, IBGP for VPNV4, VRF or VPN instance, L3VPN, and L2VPN. I hope that this is informative to you, and thank you for watching.